Hey guys, in this tutorial we will learn pandas from zero to hero. So let's start. What is pandas? Pandas is a Python library used for working with data sets. It has functions for analyzing, cleaning, exploring, and manipulating data. The name pandas has a reference to both panel data and Python data analysis and was created by Wes McKinney in 2008. Why use pandas? Pandas allows us to analyze big data and make conclusions based on statistical theories. Pandas can clean messy data sets and make them readable and relevant. Relevant data is very important in data science. What can pandas do? Pandas gives you answers about the data, like is there a correlation between two or more columns, or what is the average value, max value, and mean value. Pandas are also able to delete rows that are not relevant or contains wrong values, like empty or null values. This is called cleaning the data. Installation of pandas. If you have Python and pip already installed on a system, then installation of pandas is very easy. So, py-m and pip install pandas, run, and I have already installed the pandas. And if this command fails, then use a Python distribution that already has pandas installed, like Anaconda and Spider and etc. So import pandas. So zoom and import pandas. And now pandas is imported and ready to use. So I create a dictionary. My dataset is cars. Cars is a list. BMW, Volvo, and Ford. And my dataset has passings and 372, and I create my var is pandas dot data frame and send my dataset, print my var, save, and cls py app.py, run, and we have this data frame. And pandas has pd. Pandas is usually imported under the pd alias. So in here, pandas as pd, and use pd instead of pandas, run, and we have the same result. And checking pandas version, the version string is sorted under version attribute. So here pd.version, run, and we have this version of pandas. Hey guys, in this part we talk about series in pandas. What is series? A pandas series is like a column in a table. It's a one-dimensional array holding data of any type. So cls and a is 1, 7, and 2 or 3, and my var is pd.series a, and print my var, run, and we have this result. Index 0 is 3, index 1 is 7, and index 2 is 2. And labels. If nothing else is specified, the values are labeled with their index number. First value has index 0, second value has index 1, and etc. This label can be used to access the access a specified value. So in here we can access to 3 with myvar index 0, run, and we have 3. And create labels. With the index argument, you can name your own labels. For example, in here set index a list x and y and z, run, and remove this, or no, run, and we have this series. And when you have created labels, you can access an item by referring to the label. So in here myvar and y, and we should have 7, and 7 is here. And key value objects as series. You can also use a key value object like a dictionary when creating a series. So in here calories is a dictionary, day 1 is this, and day 2 and day 3. And so in here copy and paste myvar is pd.series and set calories. Remove this or comment, run, and we have this series. And the keys of the dictionary become the labels. To select only some of the items in the dictionary, use the index argument and specify only the items you want to include in the series. So in here index is day 1 and day 3, run, and we have day 3 and day 1. And data frames. Data sets in pandas are usually multi-dimensional tables called data frames. Series is like a column and a data frame is the whole table. So I create data variable is a dictionary, and so we have this in here, and remove, we have a list, and duration is a list, and 50, 40 and 45, and in quotes. And myvar is pd.series, no p.data frame, and data, remove the index and run. And we have this data frame. We have calories and durations. Hey guys, in this part we talk about data frames in pandas. What is a data frame? A pandas data frame is a two-dimensional data structure, like a two-dimensional array or a table with rows and columns. So data is a dictionary, and we have calories and 420, 380 and 390, and we have duration and 50, 40 and 45. And so data frame df is pd dot data frame and send data, print df, and run. And we have this data frame, calories and duration. And locate row. As you can see from the result, and as you can see from this result, the data frame is like a table with rows and columns. Pandas use the look attribute to return one or more specified rows. So print df dot look and 0, index 0, this row, run, and we have this row, calories is this and duration is 50. And note, this example returns a pandas series. And so use a list of indexes. In here, 0 and 1, run, and we have this data frame, index 0 and index 1, and named indexes. With the index argument, you can name your own indexes. So in here, index is a list, and day 1, day 3, and day 2, run. And so what's the error? Index is a list, print, so remove this, and we have day 1, day 2, and day 3. And locate named indexes. Use the named index in the look attribute to return the specified rows. So in here, look day 2, run, and we have this row. Hey guys, in this part we talk about read CSV in pandas. A simple way to store big data sets is to use CSV files or comma separated files. CSV files contains plain text and is a well-known format that can be read by everyone, including pandas. In our examples, we will be using a CSV file called data.csv. And so, load CSV into a data frame. df is pd.readCSV and send file name data.csv and print df.toString. Run, and we have these results and data. And use toString to print the entire data frame. If you have a large data frame with many rows, pandas will only return the first 5 rows and the last 5 rows. So in here, print df, run, and we have this result. So 5 last rows and first 5 rows. And max rows. The number of rows returned is defined in pandas option settings. You can check your system's maximum rows with so print. So you can check your system's maximum rows with pd.options.display.max rows. Run, and 60. In my system, the number is 60. which means that if the data frame contains more than 60 rows, the print df statement will return only the headers and the first and last 5 rows. So you can change the maximum rows number with the same statement. So in here, pd.options so display max rows is, for example, this number. So run again, and we have this result. From here to the end. Hey guys, in this part we'll go to read JSON in Pandas. Big data sets are often stored or extracted as JSON. JSON is plain text but has the format of an object and is well known in the world of programming, including Pandas. In our examples, we will be using a JSON file called data.json, this JSON file. We have max pulse, calories, and duration, and load the JSON. df is pd.read JSON and data.json. Print df.toString. Run, and we have this result. So cls, run again, and we have this result. And dictionary as JSON. JSON objects have the same format as Python dictionaries. If your JSON code is not in a file but in a Python dictionary, you can load it into a data frame directly. So I copy the dictionary, paste, and so in here df is pd.data frame, data, and this is data. Run, and we have this result. Hey guys, in this part we'll go to analyzing data frames in Pandas. One of the most used methods for getting a quick overview of the data frame is the head method. The head method returns the headers and a specified number of rows, starting from the top. So df is pd.read csv and data.csv, this data.csv, and print df.head and 10 rows. Run, and we have this result. We have 10 rows of data.csv. And note, if the number of rows is not specified, the head method will return the top 5 rows. So remove 10, save, run, and we have 5 rows of data.json. And there is also a tail method for viewing the last rows of the data frame. The tail method returns the headers and a specified number of rows starting from the bottom. So copy and paste, and df.tail, run, and we have this result, index 164 to 168. And info about the data. The data frame object has a method called info that gives you more information about the data set. So comment and print df.info, and run, and we have this info. So result explained, and the result tells us the there are 160 rows and 4 columns, and the name of each columns with data type are here. And null values, the info method also tells us how many non-null values there are present in each column. And in our dataset, it seems like there are 164 of 169 69 non-null values in the calories column, which means that there are 5 rows with no value at all in the calories column for whatever reason. Empty values or null values can be bad when analyzing data, and you should consider removing rows with empty values. This is a step towards what is called cleaning data, and you will learn more about that in the next chapters. Hey guys, in this part we talk about cleaning data in Pandas. Data cleaning means fixing bad data in your dataset. Bad data could be empty cells, data in wrong format, wrong data, and duplicates. In this tutorial you will learn how to deal with all of them. So this is our dataset in the tutorial, and the dataset contains some empty cells. Date, in row 22 we have none, and calories in row 18 we have not a number. And the dataset contains wrong format. Date in 26 is in a wrong format, and the dataset contains wrong data. Duration in 7 we have wrong data. And so in here we should have duration must be 450. Sorry, I solved this. And the dataset contains duplicates. Row 11 and row 12 are the same. So row 7 in here, change the value to a wrong value. 1 2 3 4 5 6 7 8. In here we should have 450. So run again, and so we have 450. Hey guys, in this part we talk about cleaning empty cells in Pandas. Empty cells can potentially give you a wrong result when you analyze data. So remove rows. One way to deal with empty cells is to remove the rows that contain empty cells. This is usually okay, since datasets can be very big, and removing a few rows will not have a big impact on the result. So df pd read.csv data.csv, and new df is dataframe.drop na, and print. So before print df, run, and we have empty cells in here, and here. In calories, index 18 and 28, and in date not a number in 22. So print new df dot to a string, run, and we don't have empty cell. and by default the drop now method returns a new data frame and will not change the original. If you want to change the original data frame, use the inplace equal to true argument. So in here inplace is true and remove new df, and in here df, run, and we have the same result without any empty cell. And note, now the drop now in place is true will not return a new data frame, but it will remove all rows containing non-values from the original data frame and replace empty values. Another way of dealing with empty cells is to insert a new value instead. This way you don't have to delete entire rows just because of some empty cells. The fill NA method allows us to replace empty cells with a value. So in here comment, copy and comment, and df dot fill and 130, and in place is true, run, and we have in here 130 and 28 130, and replace only for specified columns. This example replaces all empty cells in the whole data frame. The only replace empty values for one column and specify the column name for the data frame. So df and color is column and fill NA. Save and run, and in date we have not a number, but we have 130 in calories. And replace using mean, median or mode. A common way to replace empty cells is to calculate the mean, median or mode value of the column. Pandas uses the mean, median and mode methods to calculate the respective values for a specified column. So x is df calories dot mean. So in here use mean, and in here replace with mean, run, and the mean is this value, and we have this value in here, and mean is the average value, or the sum of values of all values divided by number of values. So calculate the median and replace any empty values with it. In here we have median and median, run, and median is this 291.2, and we have this number in here, and median is the value in the middle after you have sorted all values ascending. And calculate the mode and replace any empty values with it. Copy and paste mode and index 0, and replace with mode, run, and mode is 300, and we have 300 in here, and mode is the value that occurs most frequently. Hey guys, in this part we talk about cleaning data of wrong format. Cells with data of wrong format can make it difficult or even impossible to analyze data. To fix it, you have two options: remove the rows, or convert all cells in the columns into the same format. So convert into a correct format. In our data frame, we have two cells with the wrong format. Check out row 22 and 26. The date column should be a string that represents a date. So let's try it. Let's try to convert all cells in the date column into dates. Pandas has a toDateTime method for this. So df date column is pd dot toDateTime and df date and printf run again. So in here 26 we have a correct format, but in row 22 we have not a time, and so we should remove this row from our data frame. So removing rows, the result from the converting in this example gave us a not a time value, which can be handled as a null value, and we can remove the row by using the drop na method. So df dot drop na and subset is date in places true, run, and we don't have not a time value. Hey guys, in this part we talk about fixing wrong data in Pandas. Wrong data doesn't have to be empty cells or wrong format. It can just be wrong. Like if someone registered 199 instead of 1.99. Sometimes you can spot wrong data by looking at the dataset because you have an expectation of what it should be. If you take a look at our dataset, this dataset, you can see that in row 7 the duration is 450, but for all the order rows the duration is between 30 and 60. It doesn't have to be wrong, but taking in consideration that this is the dataset of someone's workout sessions, we conclude with the fact that this person did not work out in 450 minutes. So how can we fix wrong values? Like the one for duration in row 7. So replacing values. One way to fix wrong values is to replace them with something else. In our example, it is most likely a typo, and the value should be 45 instead of 450, and we could just insert 45 in row 7. So set duration is 45 in row 7. df.look 7 and duration is 45 and print run, and we have 45. And for small data sets you might be able to replace the wrong data one by one, but not for big data sets. To replace wrong data for larger data sets, you can create some rules. For example, set some boundaries for legal values and replace any values that are outside of the boundaries. So loop through all values in the duration column, and if the value is higher than 120, set it to 120. So comment and for x in df dot index if df dot look x and duration higher than 120 df dot so copy is 120. Save and run, and we have 120 in here. And removing rows. Another way of handling wrong data is to remove the rows that contains wrong data. This way you don't have to find out what to replace them with, and there is a good chance you don't need them to do your analysis. So copy and paste, and if duration is higher than 120, df drop x and in place is true. Comment this, and we don't have 120 or 450. Hey guys, in this part we talk about removing duplicates in pandas. Discovering duplicates. Duplicate rows are rows that have been registered more than one time. By taking a look at our test dataset, we can assume that row 11 and 12 are duplicates. To discover duplicates, we can use the duplicated method. The duplicated method returns a boolean values for each row. So print df dot duplicated and run, and we have this result, and 11 and 12 is a duplicated for 11. And removing duplicates. To remove duplicates, use the drop duplicates method. So df dot remove now drop duplicates in places true. Run, and we don't have duplicate. Hey guys, in this part we talk about data colorations in pandas. A great aspect of the pandas module is the curl method. The curl method calculates the relationship between each column in your dataset. So the examples in this part uses a CSV file called data.csv. This data. So show the relationship between the columns. Print df.curl and run. And note, the curl method ignores not numeric columns. So result explained. The result of the curl method is a table with a lot of numbers and represents how well the relationship is between two columns. The number varies from -1 to 1. 1 means that there is a 1-to-1 relationship or a perfect coloration, and for this dataset, each time a value went up is in the first column, the order one went up as well. 0.9 is also a good relationship, and if you increase one value, the other will probably increase as well. And minus 0 dot point value would be just as good relationship as 0.9, but if you increase one value, the other will probably go down. And 0 dot point means not a good relationship, meaning that if one value goes up doesn't mean that the other will. And what is a good coloration? It depends on the use, but I think it is safe to say you have to have at least 0.6 or minus 0.6 to call it a good coloration. Perfect coloration. We can see that duration and duration got the number 1, which makes got the number 1, which makes sense. Each column always has a perfect relationship with itself. And good coloration, duration and calories got a 0.922717 coloration, and which is a very good coloration, and we can predict that the longer you work out, the more calories you burn. And the other way around, if you burn a lot of calories, you probably had a long workout. And bad coloration, duration and max pulse got a 0.009403 coloration, and which is a very bad coloration, meaning that you cannot predict to max pulse by just looking at the duration of the workout, and vice versa.